Okay, so let's talk about that moment. You know the one. You give an AI the exact same prompt twice, and you get two totally different answers. It is so frustrating. It feels like it's broken. But here's the thing, it's not. It's actually a core feature of how these models work. And if you understand it, you can unlock their real power.
So you've definitely been here. You spend all this time crafting the perfect prompt, you get a fantastic result, and you're thinking, yes, I've got a reliable process now. So naturally, you run that same exact prompt again, expecting to see the same magic.
But you don't. You get something else entirely. I mean, it might be good, it might be a little bit off, but it is definitely not the same. And that's usually the moment you start to wonder, is this thing buggy? Is there something wrong with the whole system? It's a completely natural question to ask, but the answer is a firm no. In fact, the AI is working exactly the way it was designed to. And to really get why, we need to understand one fundamental difference. And this right here, this is the core of it all. See, we're all used to software that is deterministic. It just means it follows a fixed, predictable set of rules. But large language models, or LLMs, are fundamentally probabilistic. They are not following a script. They are making these incredibly sophisticated, calculated guesses at every single step of the way. So here's the main idea. Traditional software, like the calculator on your phone, is deterministic. 2 plus 2 will always equal 4. It's totally predictable. LLMs, on the other hand, are probabilistic. For the very same input, they can generate multiple different but still totally valid outputs. They're not just finding one right answer, they are literally sampling from a whole universe of possible right answers. This quote just nails the mechanism. Every single time an AI generates a new word, it isn't looking it up in some giant dictionary. It is effectively rolling a set of weighted dice to decide what comes next. Now, those dice are heavily weighted based on patterns from trillions of words it's been trained on, so some outcomes are way more likely than others. But there is always an element of chance in every single roll. Let's look at a quick example to make this real. If you ask an LLM for the best web development language, well, on the first run, it could reasonably say JavaScript. On the second, it might suggest TypeScript, and on the third, maybe Python. You see, none of these are wrong. They're just different valid paths the model's probabilistic dice rolling took. It's working as designed. But can we control this? Yes, we can. The main tool we have for this is called the temperature parameter. The easiest way to think of it is like a dial for randomness. If you turn the temperature down, you're basically telling the AI to stick to the most likely, the most safe answers. If you turn it up, you're encouraging it to take more risks and get a lot more creative. So as you can see here, temperature is really a game of trade-offs. If you set it all the way down to 0, you're telling the AI to always pick the single most probable next word. This gives you highly predictable output, but honestly, it can get pretty repetitive. A common default is around 0.7, right there in the middle. It's a nice balance of creativity and making sense. But if you crank it up past 1.0, you're going for wild creativity, but you're also taking on a much higher risk of errors or nonsense. And here's a key detail for developers. Even at a temperature of 0, you might still see slight variations because of the complex math happening deep inside the model. Okay, so AI is probabilistic. Why does this actually matter? Well, because if you're building anything with it, this one fact fundamentally changes your entire workflow. It forces you to completely rethink what you can and can't expect from this kind of tool. This table lays out the new reality. Let's look at the first row. You expect the same prompt to give you the same code, but what actually happens is you get different outputs every single time. So how do you adapt? You have to use detailed specs to constrain the AI, and then you have to validate everything it produces. Second row. You can't just think, oh, it gave me this last time. There is no memory, no guarantee. You have to use version control for what works and brief it from scratch each time. And finally, even for something like generating test suites, you'll get different test cases on each run. The solution? Define your required coverage up front and then merge the best results from a few different generations. And if you take one thing away from this, let it be this. Because the outputs vary, you can no longer just generate code and assume it works. You must validate that every single output, every single time, meets your requirements. It's completely non-negotiable. So how do we deal with this? How do we build reliable systems with a partner that's fundamentally probabilistic? The answer is to stop fighting its nature and start working with it, using two really powerful tools: specifications and tests. Think about it. When you give the AI a vague prompt, you're basically telling it, hey, feel free to roll the dice however you want.
You're giving it this huge space of possible answers to choose from, which is going to lead to wildly unpredictable results.
But when you provide a really precise specification, you are building guardrails. You're not getting rid of the dice rolls, but you are dramatically shrinking the space of acceptable outcomes. The variation still happens, but it happens inside the safe, controlled boundaries that you have defined.
And this brings us to the ultimate safety net, the perfect partner for a probabilistic coder, test-driven development. You know, in the age of AI, TDD isn't just a best practice anymore, it's a flat-out necessity. Your tests become this unbreakable contract. They are the deterministic, unchanging rules that any piece of AI-generated code must pass to be considered valid. The AI's implementation can be creative and varied, but the final testable result has to be constant and correct.
So far, we've mostly talked about how to control and manage all this randomness. But what if we reframed the whole thing? What if this variation isn't actually a bug we need to contain, but a powerful feature that we can harness? Because the AI is probabilistic, it can actually surprise you in a good way. It can generate a solution you never would have thought of on your own. You can literally ask it to generate 3 different ways to solve a problem, and then you get to pick the most elegant one. Every run is an exploration of a different corner of the solution space, and that is an incredibly powerful tool for creativity. This is the new mental model you need to have. Don't think of it as a consistent, reliable employee. Think of it as a brilliant, world-class expert who you can consult anytime, but who has total amnesia. Every single time you talk to them, you have to give them the full context and all the requirements completely from scratch. So the final question I want to leave you with is this. Now that you understand how it really works, take a hard look at your own processes. Are you building workflows that fight against the AI's probabilistic nature, getting frustrated with its inconsistency? Or are you building workflows that embrace it, using clear specs, solid tests, and a mindset that actually harnesses its built-in creativity? Because that choice makes all the difference.